So good morning everyone, this is CSE 213 and I am going to talk about one important topic which is BCD subtraction. If you want to take BCD subtraction or any subtraction, what we follow is we are using actually the add function, right? So adder we are using, full adder, half adder circuit we are using two techniques. In chapter 1 we studied one with the 2's complement, one with the 9's complement, right? And same way like 1's complement and 10's complement can also be used to find out the required subtraction between two number in binary or in BCD as well, right? Because BCD is an extension of binary number with the fact that it is only using the each will have the combination of 4 bits where each one of them can go from 0 to 9. It's not going from 0 to 16, which is the case for any 4-bit number, but that's not the case for BCD. It's going from 0 to 9. So if I want to subtract a minus b, note that I can use any method. One of the method might be 10's complement, 9's complement, 2's complement, 1's complement, any complement you can use it. And for explanation purpose I am using 10's complement for explanation. However, it can be extended for anything, 9's complement also, right? So how does it work? So if I want to have subtraction of two number where a and b are BCD, means individually they are from 0 to 9 for each 4 bits, right? And if you require to go with the 5th bit, then it will be 5 bits and it can go from 10 to 19, or you can go further also, and accordingly you can make the numbers, right? So for better understanding for this particular session, I am going to use 4-bit number which is A3, A2, A1, A0 and B3, B2, B1, B0. These two are 4-bit numbers where 3 is MSB and 0 is LSB for both the cases. Now what we need to do first, we need to take the 10's complement of B, which is equivalent of 9's complement plus 1. Just for your information, whenever you want to find out 9's complement, you need to invert the bits. So invert the bits, whichever number you want to make it, invert the bits, add that to 1010, and again when you are going to add that, that's the 10's complement. This is the trick to implement the same thing. So once you have the 10's complement, what you are going to do is as follows. You are going to check with addition of this with a and check the number. Let's assume that that number is x3, x2, x1, x0 with one carry k. So you are going to check k and on the basis of other inputs like x3, x2, x1, x0, as we did it last time in one of the class. C out is equal to k or x3, x2 plus x3, x1. So this function will tell you that this whole number is invalid and it's actually not in BCD. It is giving you some binary number which needs to be corrected. And how to make it correction? If it is going beyond 9, you have to add number 6. So if C out equal to 1, then you have to add 0, 1, 1, 0 in this number, and you have to find out some y3, y2, y1, y0. In this process, you might have y3, y2, y1, y0. In addition to that, you might have some carry, but ignore that carry. Okay, at this stage, if any carry, then ignore it. This is giving me the BCD addition. What we did earlier was 10's complement only, right, and plus a. So we did this, and once we have this one, keep this signal somewhere because I know that if C out is equal to 1, then the number is not negative. The BCD addition is not negative. But if it is, if C out equal to 0, understand, if C out equal to 0, then you don't have to correct those things, but it's going to give me the final number, which is tens complement of y3, y2, y1, y0, right, and with the negative sign. So this is the algorithm or the method to find out two numbers subtraction in BCD, right? So let's implement that with the required components. Let's go with that. So the first one is as follows. We are going to have 4-bit addition with two things. Look at this. Invert the bits 1010 and +1. This may be coming from the C in. This may be fed as another operand, or one of them will be addend, one of them will be agent, so that you can do it. So how to invert the bit? You can just simply take the XOR gate, add them here. So from here B3 to B0 are there, and it required to be added with logic 1 to make it invert. If you are doing it, let's use this bit. I want to add with 1010. So what I can do, I can add like this, right? So this is already added 1010 plus B3 prime, B2 prime, B1 prime, B0 prime are added, but I need to add 1. So what I can do, I can add here one carry, right? So that will give me the tens complement of number B. So you will have number available here which needs to be added with another operand, which was A3, A2, A1 and A0. When you are doing this, you will definitely have 4 numbers. So this is again a 4-bit adder. It will have 4 numbers. Let's call them x3, x2, x1, x0 and k as output bit. If this is the case, then you need to check whether this number is actually valid or not. That can be done with following things. You have C out. Now if C out equal to 1, if C out equal to 1, as per our agreement, if C out equal to 1, you need to add 0110 to this number. So let's add that with, so this is one of the operand, another operand becomes 0110. So if C out equal to 1, then it's 0110 is added. At this process, C in equal to 0, by the way, and here also C in equal to 0. This is what we are doing, the BCD addition, right? We are in the second part of the thing. The output may generate some carry. As per our understanding, if carry is generated, then you need to ignore that carry. Ignore that carry, no issue. And the output will have 4 bits, y3, y2, y1 and y0. It's again a 4-bit adder, right? So what we need to do right now, we need to see following things. If carry equal to 1, then whatever answer you got it, this is the answer, right? You should stop here. And if C out equal to 0, so what I can do, if C out equal to 0 means then this particular sign bit is getting activated, and then I need to take again tens complement. So how to take tens complement? Just invert these bits to get the nines complement. So they are getting XOR with logic 1, and at the same time I need to add 1010 as we did it in the first stage. So 1010 I can add over here, bit adder, right? It will have 4 output. Let's call them as S3, S2, S1, S0. This is the final addition, final BCD subtraction. If carry is generated, then ignore that carry. And in this process, you don't require to. So in this process, we have to keep Cin equal to 1, because it's not only inverting the bits with 1010, but you need to add Cin equal to 1 also. But in case if carry equal to 1, if carry is coming 1, then you are doing the BCD addition. However, this particular portion will be going with 0 0, so same output is coming as we were getting in y3, y2, y1, y0. So if carry equal to 0, then circuit finds tens complement, and so we can summarize this. If carry equal to 0, then circuit finds tens complement, and if carry equal to 1, circuit performs 0 plus whatever number was coming plus 0, right? So we will get the answer accordingly, right? So this is what about BCD subtraction using tens complement. Just for your home task, I am giving you for nines complement method, but I am just explaining the nines complement method. You can further use it for implementing BCD subtraction. So how does it perform the nines complement method is as follows. You have to take A minus B. In that you need to find out nines complement of B. How to find out nines complement of B? It's invert the bits plus 1010. That will give me nines complement, right? Once you have that, add that with A, find out the answer. Is it less than or equal to 9? And if it is greater than 9, then what you need to do, whatever you got the answer, plus add 0110, right? And then look at the answer. So here this carry, so when greater than 9, then C out is coming 1, right? And C out is nothing but K or S3 S2 plus S3 S1, right? So in this nines complement, we do not have to find out the final result with this carry. Understand? It is not depending on this, but it is depending on other carries. So when you are doing this, you will have the answer x3, x2, x1, x0. Along with that, you might have carry. If carry is generated at this process, then this carry has to be added to this number, and this is known as the end around carry. So if carry is created, just add that and get the number y3, y2, y1, y0, right? And this is the final answer if carry equal to 1. But if carry equal to 0, then I know that the answer is negative. And in that case, what I need to do, I need to take 9's complement of x3, x2, x1, x0 with minus sign. And how to take the 9's complement of x3, x2, x1, 0? You have to invert the bits of x3, x2, x1, x0 and plus 1, 0, 1, 0. So whatever the number is coming, that's the subtraction between A and B in BCD. So thank you very much, all of you. Thank you.